Morning, and welcome to Imperial College. There's a brilliant atmosphere out there, and I hope that you carry on being as excited as this the whole way through this Mental Maths Megastars event. So, just first of all, to yell out, has anyone here ever been to Imperial College before? Yes? Oh, so some of you have. Excellent. And put your hands up if you've been to any university before. Lots of you, that's really good. So you're going to be familiar with this type of environment. So, my name's Andrew, and I've got the job of welcoming you, and I'm the Director of Student Recruitment and Outreach, and that means my job is about finding the brightest people to come here to Imperial. And I reckon today, I'm in a room full of people who could end up coming here, because this tournament, this challenge, is going to show some of the brightest minds in maths. That's absolutely brilliant. But before I start, I've got to do a quick health and safety bit. There are no fire alarms planned today. If you hear a fire bell, just calmly go out and I'll do the airplane steward thing, either at the back, the middle, or here at the front. And we'll show you where you need to go. We've got the right slide. Excellent. So, what does Imperial College actually do to engage with young people? Well, first of all, the aim is to excite you, and by the sounds of it, we've already started doing that. So do get excited about maths, get excited about science, and really join in to support your teams here today. We try to get students to get better grades at school, and we also try to increase the number of students who come here from disadvantaged backgrounds. So that's the aim of what we're trying to do, and your aim, of course, is to try to win the tournament today. This is the second time that we've had this event. The first event was back in 2013, and indeed it's been working with one of your schools that we've managed to put this on again for you, and it's certainly our plan that we carry on doing this with you in the future. So we're now the Imperial Mental Maths Megastars. That's what you are, that's what we're going to get onto. And I just want to show, finally, the 6 schools that we have here today. You're all here, and I want to just hear how loud things are going to start off. So we're going to go from the top here. I want to hear where you are. Hampstead. Excellent. Welcome, Hampstead. Kentish Town. Fabulous. To St Michael's. St Pancras. St Mary Magdalene. Wow. You've been here before. That was very good. And last of all, St Paul's. Brilliant. I'm now going to hand you over to a maths expert who's going to say a few words about maths to you, but it's great to see you all, and I really hope you enjoy your time here at Imperial.
Hello, can you hear me? Excellent, good morning. I'm so excited that there are this many people here at Imperial just to talk about maths. How great is that? It's amazing. There are 728 seats in this room, and there are a very small number of empty ones. But more on that later. My name's Luke. I'm not really sure I'm a maths expert, as Andrew says. I'm really secretly a maths teacher. But when I left school, I came here to Imperial as a student, and I did nothing but maths for 3 years of my life. It was brilliant. Why would you not want to do that? So I'll tell you a little bit more about how that was a little bit later, because I actually managed to squeeze in a few other things as well as some maths. But most importantly, I also wrote the questions for today's final. So if the answers are wrong, it's my fault. But they won't be wrong, because you're going to get everything right. I hope the questions aren't too hard. But just before we get into that, just to kind of set the tone a little bit, I wanted to tell you a little bit about what maths is to me. And to me, maths is so important. But it's important because it's more than just counting. So let's do something. We're not going to do some counting, but we're going to do this. I'm going to tell you what maths is, and then I'm going to show you an example of how maths works at a really, really high level. But it's going to be fine. It might feel a little bit hard, but that's a good thing, right? Maths is good when it's hard. If it was easy, it wouldn't be fun. So, what is maths? Well, to me, maths is about using logic to spot patterns and prove that they exist, or prove that they apply. So those two words in green there are really, really important. Logic and proof. Try and keep those in mind. What we're going to do now is we're going to do some maths, or rather, you're going to do some maths, because I've done enough maths writing all those questions. And we're going to see what happens. So, let's do some maths. I'm going to show you some sequences. Put your hand up if you know what a sequence is. Excellent. A good, very, very good number of you. Okay, just in case you don't know, or in case you've somehow forgotten, I think a sequence is a list of numbers with a pattern or a rule. So what I'm going to do, and I'm sure you've seen questions like this before, is I'm going to show you a few numbers in a sequence, and the question is going to be, what comes next? Is that okay? Yes. Good. Is everybody awake? Yes. Is everybody ready to do some maths? Yes. Is everybody ready to do some maths? Yes. Better! Right, let's go. Okay, think. 5 seconds of thinking time. Think. Shh. Hang on. Shh. Remember I said I was secretly a teacher? You really don't want me to have to use my teacher voice. Did I say shout out the answer? Okay, think. Think means use your brain, not your mouth. Okay, try and contain that excitement just for a little bit. Okay, so the first one. When I say so, you can shout out the answer, but not before I say. So the first sequence goes 2, 4, 6, 8. Good. That was all right. What about the next one? It goes 1, then 5, then 9, then 13. 17. Fantastic. Good. Who can tell me why? Why is it 17? Now try and pick that person that I think you're at the front of the first St. Paul's row. Yeah, you. There are 2 people talking at once. This is really confusing. But fantastically, you're both saying the same thing. It's going up by 4 each time. Thank you very much. Okay, so what about this sequence at the bottom, though? So take a bit more time to think about this. Don't shout anything out yet. So this sequence goes, listen, 1, 1, 2, 3, 5. So what comes next? Okay, let's have that again in case anyone didn't hear it. Good. Really, really good. Okay. How did you know? Think about that last one. 1, 1, 2, 3, 5, 8. How do you know? Who thinks they can explain that really, really well? And really clearly, perhaps to people who might not have seen this before? Put your hands up really high so I can see you, because I'm a bit blind and I've got lights in my face. Excellent, let's go over here.
For the last one, we added up all the digits that were in the sequence, because 1 plus 1 is 2, 2 plus 2 is 4, 2 plus 3 is 5, and then...
Yep, and then what do you do next? So 5 plus 3 is 8. Okay, so what would come after that by your rule?
8.
Which is?
13.
13, good, okay. Does anybody know what this sequence is called? It has a really special name and a slightly funny name. Someone right up there at the back, yes. Say that a bit louder. Almost, it sounds like that. Someone else from the same school? Fibonacci, very, very good. I don't think I've got it written down. It's a strange name. I think it's an Italian name. Anybody know? Italian? Sounds Italian, right? Fibonacci. This is, shh, listen. This is part of the Fibonacci sequence, which is a slightly weird sequence. In the first 2 sequences, we just keep adding the same thing. But in the Fibonacci sequence, we have to look at what came before and add that on to get the next term. I'm going to show you another sequence now. Okay? I want you to think about how we worked out the rules for these sequences and how we know what we think comes next. I'm going to show you a sequence, and this time it's really, really important that you don't shout out what you think the answer is, because I might be trying to trick you, because I'm a bit mean like that. So, I'm going to show you a sequence, and I want you to think, without shouting out, what could come next, and what the rule is that would make that the next number. Is that clear? Yeah. Excellent. Are you ready for the sequence? Yeah. Remember, no shouting out. So this sequence goes, don't shout anything out yet. I'm just going to read the sequence. I don't want any shouting out. 0, 1, 2, 3, 4, 5, 6, 7, 8. Don't shout out. 9. So put your hand up if you think you've got an answer for what comes next. Loads of people. Let's go over there, right at the end of that row. Yeah, you just looked back, and I'm pointing at you. 10 because we're counting upwards. Does that sound right? Do we believe that? So I think I believe that. I think that's a very believable answer. But it's not the one I was looking for. It's not the one I was thinking of. Now, listen carefully. That doesn't really mean it's wrong. It just means that the sequence where we're counting upwards isn't the one that I had in my head when I wrote these numbers down. Because, in fact, lots of sequences can have the same starting sequence, which has these first numbers. But it's not the one I had in my head. Who thinks they can give me another one? So I've said it's not 10. Right at the back, very, very back. Yes? 0. Why? Okay, so it would loop back on itself and come back to 0. And he said, in case you can't hear him, he thinks it would be 0 because these are all single-digit numbers. So that's really good. You've spotted a pattern there. And that's important. That's what maths is really all about. We've got to spot patterns and then try and apply those patterns to what comes next. Now, annoyingly, though, for you, that's not the one I was looking for either. Now, I'm gonna be mean. I know you've got fantastic, fantastic ideas, and I would love to hear all of them. But I'm going to tell you the answer that I had in mind. So the answer I had in mind is 11. Did you expect that? Did anybody expect that? Shh. Okay. So, listen. The question now is, what's the pattern? And I'm going to show you a few more numbers, okay? So that's the first 10 numbers in the sequence, 11 numbers in the sequence. I'm going to show you some more numbers. And again, I want you to think without shouting out. But this time, think about what the pattern could be. What's the rule that connects all of these numbers together? Are we ready? Okay, here are some more numbers in this sequence. This is a really weird sequence. But see if you can spot the pattern. All right, 5, 4, 3, 2, 1. Shh. Thank you. Who thinks they've got an answer? Now remember, if you're going to give me an answer, you've got to be able to explain it. Okay? So you can guess. It's okay to guess as long as you can justify your guess. I'm going to go here in the white t-shirt on that front row. Yes?
Is the rule going up by 11?
Are they all going up by 11? Are they all going up by 11? Listen, what's the difference between 99 and 101? And what about the difference between 101 and 111? Okay, so they're not all going up by 11. Interesting. Who else has got an answer for me? Contestants, you get to answer enough questions later, so I'm going to leave you to one side for now. Sorry. You've got hard questions later, don't worry. You'll get to answer loads and loads of really, really hard maths questions that I made up for you. Right at the front. Yeah.
I think it's because you're going 0, 1, 2, 3, 4, 5, 6. Then you add when you get to 9, you add 2 to get 11.
Yeah? And then, so if we add 2 to get from 9 to 11, how do we explain the fact that we then go from 11 to 22? Okay. Let me give you a hint here. If you look at these numbers, so look at that last number, say, 121. What if I wrote it backwards? What would happen? Think about it. If instead of writing 121, I wrote the 1, then the 2, then the 1 again. Has anybody got an answer based on that? All right, shh, quiet, so that we can hear people talk. Keep your hands up if you think you've got a good answer. Shh. There, in the middle of St. Paul's. Yes? Every number is the same backwards. Perfect. If we reverse the order of the digits, we get the same number. Can everybody see that? Okay, does anybody know what numbers like this, or even words like this? We can have words. Someone shouted it out, but what did you say? Shout it louder. Go on. Fantastic. These are palindromic numbers. Thank you very much. Well done. That's really good. So, although you think of sequences as being things that go up by the same amount each time, here we've got a sequence of palindromic numbers. So here the pattern or the rule that connects all these numbers is that they're palindromic. Now, I'm going to show you something really, really hard, but I want to say something before I do that. Okay? This is what I'm going to show you. But before I show you that, this is something that seems quite simple. And one of the really cool things about maths is that we can start with a very, very simple rule and get into some really deep, really exciting, really weird stuff. And that takes a bit of getting used to. Maths is weird like that, right? We can come up with a really simple rule, like let's write down all the numbers that are the same backwards as they are forwards. But then the next thing I'm going to show you is a graph of those numbers, okay? Now this is really hard. I don't even fully understand why this happens, but maybe you can help me. So here's the graph I want to show you, okay? Look at this carefully. This is a graph of all the numbers in that sequence. And what I think is really interesting about this graph is that it sort of goes up, and it looks like it's going up at the same rate. And then suddenly, somewhere here, there's a big jump, and it changes. Do you see that? The graph is going along, and then it changes. It kind of turns a corner and goes up more steeply. Can everybody see that? So look at this corner here. So it's going up in a straight line, and then it turns, and it goes up in another straight line, but a much steeper one. That's really interesting. That's weird. Why does that happen? And the answer to that is I genuinely don't know why that happens. Now, I'm going to run out of time very soon, so I probably haven't got time to try and give you some of the ideas I came up with this morning, very early this morning, as to why this might work. But there's something really interesting going on there. So we started with a really, really simple sequence, but then we draw a graph of it, and we notice something weird. I'm going to give you a hint, which is that I think it's something to do with the number of digits in the number. But you can come and talk to me about that later, if you've got any ideas, because I need to move on. But my point here is that we can start with something simple, get to something really difficult and a bit weird that we don't fully understand. But that's fun, right? Remember, maths is not fun when it's easy. It's only fun when it's difficult. Do we agree with that? Yes. Bit unsure? Some people a bit unsure? Some people still liking easy maths that they can do. That's okay. There's nothing wrong with that. But I promise, it's more fun when it's difficult. I really promise it is. And that's kind of, for me, what today is all about. So I said that I did 3 years of just maths and really, really difficult maths here at Imperial. But I didn't just do that. I did some other stuff as well. So while I was here, I learned to go scuba diving. How cool is that? And by the end of my degree, really scarily, I was actually an instructor. That means that I get to teach other people how to go scuba diving. But that's an example of one of the many, many things you can do at university in between all the maths. Although, there is still maths and scuba diving. Don't worry. So it's not like I wasn't doing maths while I was there underwater. And here's what I do now. So I said I'm secretly a teacher. But really what I do is I work in Andrew's team here, trying to convince people like you that Imperial and like science, and particularly maths, right? Because maths is better than science. Don't tell your teachers, but maths is better than science. That maths is the best thing ever. And it also means I get to do cool things, like show a picture of Robert Winston with a Dalek. You only get that here at Imperial, people. Okay, so, as I said, this is me. That was a little bit of maths. Some hard maths. It got difficult. But don't be scared by it. Talk about it. Ask questions about it. Try and find out what's happening. And what I really want you to take away from this is keep up this amazing enthusiasm that you've shown here today for maths. Maths is so important. It really, really is the best subject ever. But we'll let you off if you go and do science later instead. That's okay too. So keep up this enthusiasm. Keep enjoying maths. It never stops being fun. It really doesn't. Most people get to secondary school and they get bored of maths. But the maths hasn't changed. Okay? The fun maths is still there. Try to remember that, even if you have to do some exams and boring stuff like that in it. So, it's now time for everybody to do some maths. Are we ready? Yeah. Okay, so, I don't know if you've been told, but there's going to be an audience quiz. Does everybody know about that? Yeah. Okay, so this is a quiz for absolutely everybody in this room. And at this point, what's going to happen is your teachers are going to give you, in groups of about 3, a pencil and a piece of paper. And this is for you to write your answer on. So teachers, if you haven't already given out that pencil and that piece of paper to each group of 3 in your school or your year, please could you do that now? All right, so it looks to me like just about everybody has got a piece of paper. Shh. I know a few of you are still waiting for a piece of paper. That's okay. Your teachers are still bringing them round. But while the last few of you are getting ready, I'm going to introduce this and tell you what you need to do. Okay. I have a message for your teachers first, which is, teachers, hopefully you know this already, but I think the maths leads in each school are going to be helping me mark the quizzes. We'll have a little huddle at the back of the room in a second so that I can tell you what we're looking for in more detail, okay? So teachers, when you've collected your answers after this quiz from your school, come and meet me at the back down here and we can go off and have a little deliberation meeting. But listen up, here we go. This is the audience quiz. So, you've got, in your group of 3, a pencil and a piece of paper, which is all you need to do some really, really great maths. And I want you to remember that this is a maths quiz, okay? So although the question I'm going to ask you may not seem like it's got maths in it, I want to see how much maths you can bring into your answer to give me a really exact, a really precise answer that is using lots and lots of really, really good maths. And remember, you will need to write all that maths down because that's the only way we're going to see your answers. Boring stuff first. On your piece of paper, in a minute, that is when we say go, you need to have written down the names of everyone in your group, what school you're from, and what year you are in as well, okay? Don't do that yet. Try and listen to my instructions just now, but you need to write those 3 things on your piece of paper. Otherwise, we won't know who's won when we get that far. This is a competition. We will be judging it within each year group, so don't worry, you're not going to be disadvantaged by being judged against people who have learned more maths than you have. That's not really what this is about. But because this is Imperial, I thought I would make this challenge about Imperial. So that's Imperial. Did everybody see this tower on your way in? Did you see it? Okay, maybe you didn't. If you came in across the Queen's Lawn, you would have seen this. This is the oldest bit of Imperial. It's called the Queen's Tower. It used to be part of a really big building that looked like the Natural History Museum, and it was really cool, but unfortunately they knocked it down and built this building instead. But we've still got the Queen's Tower, which is really, really cool. You can see it from all around London if you know where to look. Now, I want you to imagine, the problem is, having something that can be seen from all around London means that aliens notice that too, okay? I told you this wasn't going to feel like a maths question. So some aliens have noticed the Queen's Tower, and they kind of want it as their base in London. So here's the challenge. In exactly 30 minutes, some aliens are going to land on the Queen's Tower and take over Imperial. You have to get as far away from Imperial as you possibly can in that time. And what I need you to tell us on your answer sheet is how far away you think you can get, and how you're going to do that, and how you've calculated that. Okay? You have calculation. You need to work out how far away you can get. But wait, there's a catch. There's a catch. These aliens are slightly clever, and they thought that people would try to run away. So they have disabled all petrol-powered vehicles, and in fact, diesel-powered vehicles in London. Which means that the streets are gridlocked. The traffic is worse than it has ever been before. This also means you can't get a bus, right? Just to be clear. All diesel-powered and petrol-powered vehicles have been brought to a standstill. London is gridlocked. So you have got to use an innovative means of transport. Or just run really, really, really fast, okay? Listen carefully, there are more instructions. Shh, nobody should be writing yet. Shh, listen. Shh, thank you. You are going to have 5 minutes. At the end of 5 minutes, your teachers will collect in your answers. And remember, the question is, how far away from Imperial can you get in 30 minutes without using a diesel or petrol-powered vehicle? There is some more information on the slide. You are going to have 5 minutes. Remember, you must write everything down. That means show you're working and explain it. Your time starts now. No. It's got a click, I think. Next bag. It's a bit sensitive, so don't push it too hard.
I hope I don't need to touch that at all.
Oh, you shouldn't do. Yeah, no, it's fine. It's all been done for you. Your colleague just said, though, could you remind the teachers that they're not allowed to come?
Oh. Can you hear me? If I speak out...
I will... I'll take the questions.
Yes, brilliant.
I'll get them to put it back up.
Fantastic. want to stay behind the lectern. Does it work? Hello? 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 I don't think it's working. All right. Oh, there we go. Hello? Can I just remind the adults that you are not supposed to be helping the children? It's a competition for the children's minds and the children's minds only. Thank you very much. You have 30 seconds. 30 seconds. I'm going to count down. Yes. 10, 9, 8, 7. Put your pencils down, please. Thank you. Pencils down. Teachers, this is now your time. Can you please collect up all of the pieces of paper? Make sure your names are on them. Make sure your names are on them. Okay, can I have your attention, please? Can I have your attention, please? And the third and final time, can I have your attention, please? Thank you very much. Fantastic. So, or the part that you have been waiting for. I know you've been sitting for a while. So, before we do that, everyone stand up. Stretch up. Bring it down. Breathe. And sit. Okay. Welcome. Welcome to Imperial Mental Maths Mega Stars. No. That was shocking. That was shocking. Let's try that again, okay? So this hand, you know what it means. Come on, people. Let's try that again. Welcome to Imperial Mental Maths Mega Stars. That's more like it. That's more like it. Okay, so we all know why we're here. We are here to have a fabulous mental maths competition. I want you all to try your hardest, that's talking to our contestants, and I want all of the audience to cheer your contestants on as much as you possibly can. It's going to be very, very nerve-wracking for them to be up here. As Andrew said earlier on, we started this in 2013. It was an idea that came from one of my maths teachers who used to work with me a couple of years ago, and we're hoping that we can continue this with the support of the wonderful Imperial College, because without them, this would not be taking place. So can we stop and give them a massive cheer and thank you before we go any further? The reason why we wanted it here is because this is something for you to aspire to, okay? This is somewhere that you all should want to go when you get older. And the only way to get here is through hard work. But every single one of you can make it. And that's what you need to remember, okay? And it starts today. It starts now. Yes, come on. Fantastic. Okay, so please can I ask for our wonderful Year 4 contestants, as you are first, to make your way onto the stage. Can we give them a round of applause? Okay. And quiet, please. And quiet, please. And a little bit of quiet, please. I need you to listen. I did it that way on purpose because I knew that that's exactly what would happen. You are all too excited, and that's brilliant. But you need to listen for me. You need to listen to my voice. And when you hear my voice, you need to dance. Not quite. When you hear my voice, you need to stop, okay? And it just did. Now, before we get even more excited, there's something important that we need to do, and those are the questions. Now, those of you who know me know that my name is Mrs. Reed and that I am the head teacher of St Mary Magdalene Primary School. Thank you. I brought my own fan club. However, we don't want there to be any confusion as to where the questions have come from. They have nothing to do with our school. We are just as blind as you are. So I'm going to ask the wonderful Luke to please hand me the sealed envelope of questions. And I'm going to dramatically open them. You can do a drum roll. Oh no, oh no, oh no, oh no, oh no, oh no. You know, with a drum roll, it's got to stop somewhere. Pay attention. So I have Year 4's questions here, okay? I'm going to open the envelope for Year 4's questions. Year 4, are you ready? Are you sure? Can we please have a buzzer check to make sure that all the buzzers are working and so that nobody is at a disadvantage? So if I ask you one by one to press your buzzer, wait for your your school, and then you'll know. So, St. Mary and St. Pancras, can you check your buzzer, please? Now, that was not the sound I was expecting. Is that right, though? Fantastic. St. Paul's. No. and we'll start again. Is that not the buzzer sound? Somebody who, technical people that we pretend aren't here but are definitely behind the scenes. Should we try again? Okay, St. Paul's, can you try yours again? Try again. Fantastic. Pardon? They're resetting. Hampstead, can you try yours, please? Fantastic. St. Michael's. Kentish Town. Thank you. And Mary Maggs. Mary Maggs.
Phenomena.
Fantastic. Okay. So, I hope that you all know the sound of the schools. I might get a little confused. Contestants, you cannot answer the question until I say your school name. Make sense? Yes? So even when you press the buzzer, you need to wait for me to say your school name, and then you may answer the question. If the question is wrong, we will give you an opportunity to try again, the whole group of you, so you can press the buzzers again. Make sense?
Yes.
Fantastic. Are we ready? Yes. Are we steady? Yes. Then can I have silence in the audience, please, to be fair to the contestants? Thank you very much. So, Year 4, Imperial Mental Maths Megastars, here are your first question. Imperial has 15,291 students. What is this number rounded to the nearest 100? Is the light on them? Is the light actually lit up the one that's singing? Is that Kentish Town in the middle? Oh, good. Kentish Town.
15,300.
Excellent. Well done. Excellent. Question number 2. I spend £2.73 in a shop. How much change should I receive from a £5 note? St. Mary and St. Pancras.
£3.27.
Excellent. Well done. No. Sorry. No. Sorry, how much did you say? No, sorry, it's not £3. Sorry, my fault. I heard wrong. That would be St. Paul's.
£2.27.
Well done, St. Paul's. £2.27. Sorry. I heard wrong. Question number 3. How many millimetres are there in 2¼ litres?
Phenomena.
Mary Maggs.
200 millilitres.
Sorry, Mary Maggs?
200 millilitres.
Not quite, Mary Maggs. No. Out there again. St. Mary and St. Pancras.
2025.
Not quite. Kentish Town? Not quite. Shall I read you the question again? I'm going to read you the question again. It's 2 and 2. 2 and 2. I have not done the questions. They have nothing to do with me. Which team was that was correct? That was Kentish Town. I'm so sorry, Kentish Town. Well done. We may get Luke to check through the questions again. Okay. Question number 4. We do apologise, Kentish Town. Question number 4. What is half of 376?
Phenomena.
Mary Mags?
183.
Not quite. Kentish Town? No. Who's that? It's not lit up. Who was that? It's not lit up. Buzz again, buzz again. St Paul's.
188.
Yes, well done, St Paul's. To get these buzzers working. Okay. Yeah. Okay. Can we have silence, please? Can we have silence, please? We do apologise for a few technical issues. Can we just check the buzzers again, please? St Mary and St Pancras. Yeah? And are the lights working when they buzz? Because I can't see which schools are saying. Perfect. Okay, fantastic. I don't have a question yet. Are we ready? Okay, question number 5. Andrew saved 5 pence pieces. He saved £7 and 60 pence altogether. How many 20 pence pieces is that?
Phenomena.
Mary Mags?
There we are. I don't know.
Okay, that's fine. Buzzers on again. Kentish Town? We're going to start the question again. We're going to start the question again. I'm so sorry.
152, just remember.
The question. Can we have silence in the audience, please? Thank you very much. Okay, we're going to start the question again because we thought there was a little confusion. So, Andrew saved 20 pence pieces. He saved £7 and 60 pence altogether. How many 20 pence pieces is that? No, not quite.
Phenomena.
Mary Mags?
734.
No. Do you want the question again? St Michael's. Well done, St Michael's, 38.
No, you've answered 2 questions.
You should. Don't go anywhere. Are we ready? Can we have quiet in the audience, please? Thank you. I will not answer the questions or ask the questions until there's silence. You need to be fair to the contestants. If you're talking, the contestants are not getting a fair chance to answer the questions. Thank you. Okay, question number 6. What I'll do is I'll read the question through twice, okay? So I'll read it through the first time, no buzzers, and then I'll read it through again, and then you can answer. Did everybody understand that, contestants? Yes? Twice, okay. Question number 6. A rectangle has a length of 12 centimetres and a perimeter of 36 centimetres. What is the width of the rectangle? I'll read it again. A rectangle has a length of 12 centimetres and a perimeter of 36 centimetres. What is the width of the rectangle? St. Mary and St. Pancras?
12 centimeters.
No. Kentish Town? Well done, Kentish Town.
I knew it! So it's 12 and 24.
Question number 7. Question number 7. Add 10 to minus 3. Add 10 to minus 3. It's fine.
Minus 3 meaning 7.
No.
Phenomena.
7! Yeah! 7!
Mary Mags?
7!
Yes. Contestants. What? Check their buzzer. Hampshire Parochial. Hampshire Parochial, can we check your buzzer, please? Just give us a moment. It's very, very nerve-wracking up here. This is why you need to be fair to the audience, to the contestants. You need to be really calm before the answers are given. And it's okay to get excited and cheer your team, but you need to go back quietly as soon as you can. Are we good to go? Okay, fantastic. Well done, contestants. I'm just going to change it again, and I'm actually only going to read the question once. I think twice kills it a little bit. So, you're only going to get the question once, contestants, okay? Just once. Right, question number 8. I think of a number, subtract 17, and then double the answer. I get 32. What was my number?
Phenomena.
Mary Mags?
15.
Not quite. Kentish Town? No. Would you like me to read the question again? Okay. I think of a number, subtract 17, and then double the answer. I get 32. What was my number?
Phenomena.
Mary Mags?
16.
No.
Huh? 1902?
St. Paul's?
21.2.
That's okay, it takes some getting used to. No, that's not the answer. St. Mary and St. Pancras?
21.5.
No, I don't think we need to touch the microphones. And no, that's not quite the answer.
Phenomena.
One more go. Mary Mags?
33.
Yes. Well done. Question number 9.
Coming, I think.
Silence in the audience, please. Thank you very much. Question number 9. What is 236.3 multiplied by 10?
Phenomena.
Mary Mags?
232.30.
No. Sorry, Mary Mags. St Mary and St Pancras?
2,363.
Excellent. Well done, St Mary and St Pancras. Pardon? He said 2 point something. He didn't say 2,000. Please do not question. Thank you very much. There we go. Question number 10. In a mental maths quiz, 45 contestants from a total of 50 could not answer the last question. What percentage of contestants could answer it? St Mary and St Pancras? No.
Phenomena.
Mary Mags?
5.
No. Would you like the question again?
No.
In a mental... Audience, please. Thank you. In a mental maths quiz, 45 contestants from a total of 50 could not answer the last question. What percentage of contestants could answer it? Kentish Town. Well done, Kentish Town. I am going to assume that someone's taking... that someone's doing the... Fantastic. Is it a tie anywhere? No. Well done to our Year 4 contestants. Can we please give them a huge round of applause?
They've won.
Year 4 contestants, you may step down. Please tell me you took them. Have a look. Brilliant. Brilliant. Oh dear. I'm confused. Is it year 5 now? Or is it year 3?
There's a video there.
Yes, after. So I think it's...
So that was...
it's year 5 now.
okay.
I did it the wrong way around.
okay.
It's year 5
Year
first.
5 now, and then...
Yeah. Can we please give our Year 4 contestants a huge round of applause? Well done, Year 4. It's very, very difficult being the first contestants to come up. I think you handled it incredibly well. I do apologise for some of the technical issues. We hope we've sorted all of those out. But if we haven't, we'll just keep going, as we always do. So, in the name of the game, the Imperial Mental Maths Megastars, can we please invite our Year 5 contestants up? A little eager there, Kentish Town. I'm about to open the questions for Year 5. Thank you, audience. Year 5 contestants, are you ready? Yeah. Good. We'll start your questions. Question number 1. What is 560 divided by 7? St. Paul's. Yes, well done, St. Paul's. Thank you. Question number 2. A function machine changes 27 to 54 and 49 into 98. What function is the machine carrying out on each number?
Phenomena.
Mary Maggs.
2.5.
Not quite, Mary Maggs. Hampstead Parochial.
It's timesing the numbers by 2.
Yes, that's fine. Well done.
Phenomena.
Question number 3. How many 6-centimetre lengths can you cut from a 35-centimetre piece of string? St. Mary and St. Pancras. Well done, St. Mary and St. Pancras. Question number 4. Tell me a 2-digit number that is a multiple of 6 with digits that add to 6.
Phenomena.
Mary Maggs.
12.
No. Kentish Town. Well done, Kentish Town. Question number 5. What is the square root of 64? St. Mary and St. Whoa. St. Mary and St. Pancras.
8.
Yes, well done. Yes, St. Paul's. We'll just check. Can we have a check on St. Paul's and Hampstead Parochial, please? Yep, it works. And can we have a check on Hampstead Parochial? It does work. Guys, there's such... No more buzzing. No more buzzing. That's why we have the lights that light up on you, okay? Because it's so close when you're all pressing that the actual first person to press, their light will come up, all right? That's why I say wait, because I have to wait and see where the lights come. Yeah, exactly. Righty-ho. Question number 7. No, question number 6. Really? I haven't asked the question yet. Okay, question number 6. How many vertices does a triangular-based pyramid have?
Phenomena.
Mary Maggs.
4.
Well done. Thank you, Mary Maggs. Question number 7. What is the value of 7y minus 4 when y is 4?
Phenomena.
Mary Maggs.
70.
Not quite. St. Mary and St. Pancras.
171.
No. Kentish Town.
24.
Well done, Kentish Town.
Phenomena.
Question number 8. Getting a little bit buzzer happy, I feel, year 5. Question number 8. Add 3/4 to minus 1/2. St Mary and St Pancras.
Is the answer 3/4?
No. Hampstead Parochial. Well done. Question number 9. Each row of seats in the Great Hall has 30 seats, and half of them are occupied. If there are 20 rows, how many people are seated in the Great Hall? St Paul's? No, not quite. St Michael's? Well done, St Michael's, 300. And the last question, question number 10. Can we have silence again? Thank you. I think of a number, add 1, divide it by 2, and add 3 to the answer. It would be interesting what you come up with, Mary Mags, because I haven't finished the question. Sorry?
70.
No. I shall start the question again. A little bit of silence, please. I think of a number, add 1, divide it by 2, and add 3 to the answer. I get 7. Let me finish the question, Mary Mags. I get 7. What was my starting number? Hampstead Parochial.
13.
No. St Mary and St Pancras.
7.
Well done. Scorers, how are we going? Do we have a tie? No. Fantastic. Well done to our Year 5 contestants. We're not going to... Is that Year 3? Can we give our Year 5 contestants a huge round of applause? Well done, Year 3. Can we just acknowledge that these are our youngest contestants up on stage? Can we please give them a wonderful round of applause? Okay, Year 3, are you ready? Excellent. Silence in the audience, please. Thank you. Question number 1. Round £4.74 to the nearest 10 pence. St Paul's. Well done, St Paul's. Mary Mags, you need to wait until the answer is answered before you keep pressing the buzzer, please. Question number 2. Subtract 16 from 73. St Mary and St Pancras. Well done. Question number 3. A train was due to arrive at 11:05 in the morning, but was 20 minutes late. What time did it arrive? St Paul's. 25 minutes past 11. No, St Paul's. Mary Mags.
5:50.
Sorry?
5:50.
No, Mary Mags. Hamster parochial?
5:31.
No. Would you like me to read the question again? Who's that? Kentish Town? No, listen to the question again. I think you're listening to the first part and you're not listening to the rest of it. Listen very carefully. A train was due to arrive at 11:05 in the morning, but was 20 minutes early. What time did it arrive, please? Hamster parochial.
25 past 5.
No, sweetheart. Mary Mags?
4:45.
No. I think we might move. Oh, one more. Let's go. St Paul. Yes, St Paul's.
4:40.
No. Listen to the question. No. Stop. Listen to the question. Listen to all. No more buzzers. No more buzzers. Listen to the question. Silence in the audience, please. Thank you. A train was due to arrive at 11:05 in the morning, but was 20 minutes early. What time did it arrive? Hamster parochial.
11:25.
No. Mary Mags.
10:45.
Yes. No, they just to 5. Okay, well done. Question number 4. Double 1,234. Mary Mags.
4,000.
No, Mary Mags. St Michael's.
2,460.
Excellent, well done. Question number 5. Silence, please. Thank you. Jenny has £4.50 and buys 2 sandwiches costing 75p each. How much money does she have left? St Paul's. I think I read that question wrong. I'm sorry. St Paul's. That's my fault. I'm going to read it one more time. I might have read it right, but now I'm a bit confused. So I'm going to read it again. I'm so sorry, St Paul's. Question number 5. Jenny has £4.50 and buys 2 sandwiches costing 75p each. How much does she have left? Mary Mags. Yes, Mary Mags. Well, I did read it right. What? Question number 6. This stage, thank you. This stage is approximately 11 metres across. How many centimetres is that?
Phenomena.
Mary Maggs.
1,100.
Well done, Mary Maggs. Question number 7. What is 2% of 4,000? St Paul's. It's okay. Not quite, St Paul's.
Phenomena.
Mary Maggs. The question, I'm going to read the question again, but you have to go back to buzzers. The question is, what is 2% of 4,000?
Phenomena.
Mary Maggs.
80.
Well done, Mary Maggs. Question, calm down please. Question number 8. What is the smallest whole number that can be made with the following digits? 3, 7, 2, 0.
Phenomena.
Mary Maggs.
200. Yeah. 200, 3,720.
No, Mary Maggs. St Michael's.
2,307.
No. The smallest whole number. Mary Maggs.
2,300.
No. St Mary and St Pancras. Well done, St Mary and St Pancras. Question number 9. Shh, shh, shh. Audience, please. Thank you. Today is Friday, the 1st of July 2016. What day of the week will the 20th of July 2016 be?
Phenomena.
Okay.
Mary Maggs?
Sunday.
No. St Mary and St Pancras?
Thursday.
Sorry?
Thursday.
No. What day? Kentish Town? Yes, well done, Kentish Town. Question number 10. Silence, please. In the equation x minus 17 equals 25, what is the value of x? St Paul's? Well done, St Paul's, 42.
Phenomena.
No, the question has been answered. No more pressing of the buzzer. Thank you. Do we have a tie? No, fantastic. Can we give our youngest contestants year 3 a round of applause? If we are nearly at the end, can the Year 6 contestants please take the stage? Oh, brilliant.
I just don't know if I need to write.
No, I don't think we need to test the buzzers anymore. Okay. Right. These are our eldest contestants. Are you ready, the eldest contestants? I clearly think that you are. Can we please wait until I've finished reading the question before the buzzers go? Okay. Question number 1 for our Year 6 Mental Maths megastars. I need silence in the audience, please. Thank you. What number is 3 less than 2.5?
Minus 0.5.
St Paul's, yes it is. Well done, St Paul's. Question number 2. Question number 2. Thank you. I think the buzzers are very sensitive, but I don't think you know what I'm about to say, so I'll read the question. Question number 2. Round 8.759 to 2 decimal places. St Paul's. Going to have to press you for an answer, St Paul's.
8.76.
Sorry.
8.76.
Well done, St Paul's, 8.76. Question number 3. Quiet, please. Thank you. Name a 3D shape with 12 edges and 8 vertices. St Michael's. No. Well, yeah. You need to name the 3D shape. Hamster parochial. Well done, hamster parochial. And you know what you did wrong down there, yes? Okay, fantastic. Because technically, yes, you are right. Okay, question number 4. If y equals 4 times minus 3, what is the value of x when y is 13? X. Yes, let me read that again. Let me read it again. Let me read it again. Let me read it again. No. I just said, let me read it again. Thank you. Audience up there. What did I say about listening for my voice? Thank you very much. If y equals 4x minus 3, what is the value of x when y is 13? No. St Paul's.
4.
Well done, St Paul's. Question number 5. Divide minus 28 by 7.
Phenomena.
Mary Maggs.
4.
No. St Mary and St Pancras. Sorry, St Michael's. Sorry, my fault.
-4.
Well done, St Michael's. -4. Question number 6. Listen in. Thank you. I'm waiting. Thank you. Water flows from a tap at the rate of 10 litres per minute. How much water will flow if the tap is left on for 1 hour and a half? Hampshire parochial. Sorry, sweetheart? Well done, 900 litres. Question number 7. There are 760 seats in the Great Hall and 19 seats in each row. How many rows are there? St Paul's?
760.
No. How many rows are there? Yes. There are 760 seats in the Great Hall and 19 seats in each row. How many rows are there? St Mary and St Pancras?
50.
No. Press your buzzer. St Michael's?
10.
No.
Phenomena.
Mary Maggs? Yes, 40. Question number 8. What is the largest number that can be made using the digits 0, 1, 5, 7, 9, which is not a whole number? I think you're going to need to press your buzzers again, because that was Mary Maggs. Mary Maggs, I need an answer. No, Mary Maggs. Hampshire parochial.
Phenomena.
Yes, Hampshire parochial. Please. Yes, Hampshire parochial. Please stop. If you keep pressing the buzzers, you can't actually hear that somebody's already answered the question. That was Hampshire parochial, and they got it right. Sorry? You don't think your buzzer's working? Have a press of it, please. It is. Okay. It's okay. Question number 9. 16 apples in a crate are red. 40% of the apples in the crate are red. How many apples are in the crate, please, St. Michael's? Guess a number, because you pressed your buzzer.
Phenomena.
No. Mary Maggs? No. Wait for me to say St. Paul's.
40.
Yes, well done. Oh dear. Question number 10. And I think the last question. A train was due... Thank you. A train was due to leave at 11:48, but was 1 hour and 33 minutes late. Using the 24-hour clock, what time did it depart? Kentish Town.
13:90.
No. Hampshire parochial.
13:22.
No.
13:21.
Yes, St Paul's. So close, so close. Are we tied? No. Okay, can we please give our Year Sixes a huge round of applause? Well done, Year Six. Okay. Okay. Can we thank you very, very much for all of our wonderful contestants. Whilst we are just setting up for the prize giving, the awards, all the excitement of the day, I think that we need to say a huge thank you to all of our teachers for helping to bring you here. We need to say a huge thank you to yourselves for working as hard as you did. Can we say a big thank you to our maths coordinators who have been working on this over the last couple of months, and especially to the maths coordinators, the school business manager and the Year 3 teacher at Mary Maggs, because I know they've put a lot of time and effort into getting this together. And just because we can our contestants stand up one more time? Stand up where you are. Turn around and face your audience. Give them a round of applause. You did a wonderful job. Well done, contestants. Well done. So whilst you're waiting, you've been sitting for a long time again, everybody stand up. Everybody stand up. Everybody on their feet. Everybody stretch up high. Touch the sky, I heard someone say. Everybody stretch down low, touch your toes. And up high again. And clap your hands together. Faster. Well done, sit down. So, before we find out the winners of the competition and obviously the individual school winner, I'm going to hand back over to Luke, who's going to tell us the winners of the audience question. And you're going to get certificates out, right? And I'm going to give it.
I'll do it in order. Year 3 first. All right, so thank you to all of you who submitted some really great answers to this question in the very, very short space of time that you had to do it. Before I read out the winners, I would just like to give a few highlights from some answers that I particularly liked. So let me just highlight one of those. I'll find the one that I really liked here. So one I particularly liked ended. And I'm not saying whether these have anything to do with the winners yet or not, by the way. But this is one that I liked. It ended in the phrase, hope they can't swim, which I thought was quite good. And this one involved getting a Boris bike and cycling to Regent's Park, and then get a rowing boat and row as fast as we can to get away, and hope that they can't swim. So I thought that was a really nice answer. There were some other very, very ingenious answers as well, involving solar planes, and hiding in secret places at Imperial. But what I'm now going to do is I'm going to read out the winners in each year group. However, I would like you just to save your applause until we've read out all 4 year groups winners, and then we'll get everyone to come up at once, okay? So there'll be one team from each of year 3, 4, 5, and 6. But let me read all of them out before we applaud. Try to control yourselves. Are we ready? Okay, so from year 3, the winner, using a horse to travel 7 miles every 5 minutes, was from St. Mary Mag's, Alicia, Lorang, and Sophia. I hope I'm reading your names right. The lighting's a bit weird here, okay? You can get ready to come up, but no applause yet. From year 4, Miss, will I get all 4 year groups up first, if that's okay? From year 4, from Kentish Town. The answer was, run to the Royal Albert Hall and hide there until they're gone, for a total distance of just over 200 metres. That was Ishan and Jude. Could you come up, please? Listen carefully for year 5. Shh. Using a nifty combination of cycling and roller skating, from St. Michael's, we have Samuel, Jabrel, and Chrissa. Sorry, am I reading your name wrong? I can't read your writing. You should write more clearly. And finally, finally from year 6, using a true Imperial solution to this problem, a solar panel plane, which can apparently travel at 600 miles an hour, giving a total distance of 300 miles in the 30 minutes allowed. From St. Michael's again, we have Rahima and Renal. Could you come down, please? Well done to all of those winners. Thank you very much.
So, what we have finally been waiting for. I would like to invite up onto the stage Mr. John Nielsen, who is the Imperial College Secretary and Registrar, but he is also, and probably more importantly, a mathematician. Can we welcome up Mr. John Nielsen?
Thank you.
Do you want to say any words before?
You keep going.
I'll keep going. Okay, so we are going to very quickly find out who are the individual year group winners and then find out who the whole school winner is. So I'm going to get my envelope, and what's going to happen is we're going to have the winners come up first. We're going to give them medals and then we'll invite all of the contestants from that year group to come up, because we have a goodie bag for all of the contestants, because they've all done an amazing job to sit here in front of you all and try and answer those questions. So everybody is going to go away with something. So, year 3 winners, I've been handed gold envelopes. No expense spared here. So the winner of the year 3 competition is St. Mary Magdalene. The Year 4 winners, Kentish Town. Well done, Kentish Town. Well done. Okay, our Year 5 winners. St Mary and St Pancras.
So we're not going to put them all in the sand. Just a number in front. Yeah.
I was going to say, surely. Fantastic. And our Year 6 winners, St Paul's. Okay. So, huge congratulations to the individual schools, but we are a team, and I have the envelope of the winning school that is going to go home with this rather shiny, very large trophy. And the winning school that weren't long enough. Like Ant and Dec do it much longer, much longer. X Factor, all of those things, much longer. St. Paul's! Absolutely